Part A wants where f has a relative maximum. So remember that when you're looking for maxes or mins, you're going to be looking at the derivative, but you have, this is a graph of the derivative. So derivative picture, derivative sign chart, you should look for above and below. So we are above the x-axis until we get to 2. Then we are below until we get to 5. And then we've got 6 as one and 0.0 as the other. Please always label your sign chart. In this case, it's f prime. We are looking for a relative max, and they actually did not tell us to use the endpoints, so then my only maximum here then would be at x equals 2 because, oops, I never put a plus sign there, sorry, because x equals 5 would be a min. Now, please state clearly, because this is not sufficient. You can't just have what I have here, a sign chart, and then x equals 2 is a max. So there is your explanation. X equals 2 is a relative max because f prime changes from positive to negative. Please don't forget, you must say about this point. Some of you are forgetting to do that, okay? This was a tricky question. I just want you to notice that here it does ask for a relative minimum. So kind of like part A, you have to do a sign chart, right? But sign charts, in this case, I would need a G prime sign chart, but I do have I have a set of values for G prime. Here's the problem. Some of you are trying to do a sign chart from this. Guys, you really don't know what's happening in between 0 and 2 here. So one of you very smart people, you know who you are, you actually plotted these points to get what the curve would somewhat look like, which is great. That's a really great idea. So, and you can just sketch it. So I have 0, 4, then I have 2, 0, and this is up at 4. Right, then I've got 4, 2, so I'm going to put that right around there, and that's going to be 4. And then I have 6, negative 2, so I'll put that right about here. Now this is a curve, so roughly speaking, it's going to look like that. Now this is the graph of g of x, but now it would be pretty easy for us to get a sign chart based upon g of x, right? We want a sign chart for the derivative because we're looking for a minimum. And if we have a graph of the actual function, what do we look for when we're doing a derivative sign chart? We should be looking for increasing, decreasing. So you notice that that graph is decreasing until you get to negative 2. Then it increases until 4, and then it decreases after that. Now let's answer the question. It says, at what value of x does g of x have a relative minimum? So then your minimum, oh, did I have a negative 2? That shouldn't be a negative 2. That should be a positive 2, shouldn't it? So that is your relative minimum. And like part A, this would be your explanation for part B. All right, I'm going to be honest with you. I really don't love the wording of the first sentence because it's kind of vague on what they want. There were a couple of you that actually understood what you were supposed to do, but this one is asking you to write an expression, kind of like a formula, just a general formula. So they want you to write an expression for f of x that includes an integral. So they're telling you you're going to have an integral in it, and then we're going to be using that expression to find your f of 2 and your f of 5. All right, so just be careful because you need to remember or notice that what they gave you up here is an initial condition. And you've had this in a couple of your videos that you've done already. So basically, if we want to write an expression for f of x, obviously we write f of x equals. You always have to have that initial condition, and then it will be plus some integral. Now, remember, this -2 is coming from this value. So the x value that corresponds with that is supposed to be your lower bound. So then I'm going to have a 0 here. And I don't know how far up I'm going, so I'm just going to keep it vague and write x. And then if I take the integral of f prime, then that would give me the area under the curve. All right, so let me explain that again. So this is my initial condition. I have to use the x value that corresponds with that initial condition as my bottom bound. I don't know how far I'm going, but remember, an integral just basically means area under the curve, and it means the area under this curve. Because this is f prime, to find f, I would integrate, in other words, take the area under here, and in here. Okay, so that's why this says f prime, because if we integrate f prime, we'll get that area under the curve. So that's your general expression. So that's the answer to the first part. All right, now, the second part they wanted you to find was f of 2. So we're going to just start by putting in -2 plus the integral from 0 to 2 of f prime of t dt. Okay, seems easy enough so far, right? All right, so we know that f of 2 is going to be -2 and then plus something or other, right? Well, let's talk about that something or other. It's the integral from 0 to 2 of the graph. So let's look at what happens from 0 to 2. Couldn't we just take the area of this triangle and add it to -2? Okay, so if you take a minute, why don't you find the area of that triangle? So the area of that triangle is going to be 2, right? Plus the -2, which would give me 0. So my f of 2 is 0. All right, now we need to find f of 5. So we're going to do the same exact thing again. So f of 5, -2, plus, and then I'm going to integrate. I'm following that formula in the first box. 0 to 5 of f prime of t dt. So let's go up. Let's look at the picture. So here is 0, 1, 2, 3, 4, 5, all the way out to here. So then I would be finding the area of this triangle, which, remember, we know what that is. That's 2. And then I'm going to be subtracting the area of this triangle. Why am I subtracting? Because that triangle is underneath the x-axis. All right, so, oops, I thought I had my pen on. F of 5 is going to be -2. Now we know, again, the area of the triangle from 0 to 2, we know is +2. Now I'm going to put a minus here, and now I'm going to find the area of the triangle that's underneath the x-axis. So take a minute and figure out what that's going to be. So the area of that triangle is 3/2, but I'm going to be subtracting because it's underneath the x-axis. So then our final answer for f of 5 is going to be -3/2. They want the absolute, that's an important word, minimum value, that's another important word, value, and they're putting it on a closed interval. So we know that we have to use endpoints here. And they are talking about f prime. So actually I could go back to my part A and just copy that sign chart over again. So I've got 0 and 6, then I had 2 and 5 here, and I had plus minus plus. So we're looking for a minimum. Well, I know I have a minimum right here at 5, which makes 6 a max. I know 2 is a max, so that means 0 has to be a min. Now, I want the absolute min, so I want to see which one is the absolute lowest. So I need to know what is f of 0. It's right there. So that's -2. That was easy. All right, then the other thing that I'm going to need to know, though, is I'm going to need to know f of 5. Oh, well, didn't we know that on part C? And part C, that was -3/2. Now, I want to stop a minute because one of you guys was saying to me that I didn't know how to do something. That wasn't this particular question, by the way, this particular part. But this person knew how to fake it. And that's the name of the game here. So this is what I want to talk about. So let's say on part C, you did not get f of 5. You had no idea what it was. Then on part C, you should make it up. Pick a number, any number, okay? And then now, here you are on part D, and you need to be comparing these two answers, correct? Well, listen, if you picked a number and it's an incorrect number, but you know which one is more min, they're giving you full credit for it. They'll take off on part C, but they're not going to take off on part D because you understand the concept. So guys, it's really important. Just fake it. If you need a question, if you need an answer from a previous part, just make up a number and then use it. And if you use it correctly here, you're good to go. Okay? So that's why I say always write everything and anything, because chances are you remember something. All right, well, let's get back to it though. So my absolute minimum value is -2. So absolute min value is -2. And here is your explanation. All right, there's two ways to do this question. A lot of you chose to try to draw a picture of G prime, which I'm totally okay with now. So basically, they were plotting 0, -4, 2, 0, 4, 0, and 6, -4, which I have right here. Now, the one thing that you're not really sure of is what happens in between 2 and 4. I mean, this could go up like that and be sort of upside down parabola-ish, or it could come back down and da-da-da-da. But you know what? Honestly, and I'll show you why in a minute, it really doesn't matter. So what I noticed most of you who did draw a picture, you drew this. Okay, and again, if I were you and you had this question on your AP, you better label what you just drew a picture of. So, and here's why it really doesn't matter what you did in here, and I'll show you. They want to know where this graph, or if this graph, is equal to -2 at some point. Well, here's -2. This is y equals -2. And you can see, if you read the question, it says, is there a value of c such that at that value c, it's an x value, the y value will be -2? Well, yes, there is. Here's one spot. Here's another. Now, they just want to know, is there a value of c? Just one. And yes, there happens to be more than one. 1, 2. Now, depending on how you drew this part, like this part could have come down and hit it again, but it really doesn't matter. They just want to know, is there going to be at least one? And your answer is yes, there is. But listen, if you're going to do it this way, you need to show this picture. You need to show this. You need to label this. You need to label that this is G prime, because this is a better explanation as to why. So you can say yes because the line y equals -2 hits the graph in at least one spot. And there's your explanation. Alrighty, so if you look at the question here, all I did in this step right here was I plugged in the 2 in both spots for x here and here. Now, most of you knew that you were to go to the chart and you were to find g of 2. Easy enough, right? So, and you all had that right, so that was 0. Here's the part that you didn't have, and it was because, honestly, you didn't have this from part C correct. So if you go back now and look at your part C that we did, you should see that this is not actually a numerical value other than 0, I should say. You guys had some numerical values and they were not 0. So that is, if you look at part C, that is 0. So that's an indeterminate. There were a few of you that did have that. Now just remember, if that happens, then you're supposed to apply L'Hopital's rule, which one of you did do. I was so excited. And that is basically taking the limit again, but you're going to take the limit at f prime of 2 and then g prime of 2. Well, I don't have the picture in front of me, but look at the picture of f prime. Go to where x equals 2, and do you see that it hits the x-axis? So that means f prime of 2 is 0. Now you have the chart, so look at the chart, find g prime of 0, g prime of 2, and you'll see it's 0. Well, womp womp, we've got indeterminate again. Well, L'Hopital's rule just says, hey, guess what? Just keep going. So now what we're going to do is we're going to do f double prime of 2 and g double prime of 2. Okay, so the only thing that you have to be a little careful of is when you're doing double prime of 2, you have an f prime picture. So if I want f double prime, I'm basically looking at the slope of f prime at x equals 2. So if you look at the slope when x equals 2, that's negative. And if you count boxes, that's down 1 over 1. So then f double prime of 2 is negative 1. All right, g double prime of 2, go to the chart, and there it is. And there's your answer.